let's review this. So our directions are asked to convert from degrees to radians, or vice versa, and round our answer to the nearest hundredth. So we have 31 degrees. Note the degree sign. So to convert 31 degrees to radians, I need to multiply by pi over 180. So that's going to give me 131 pi over 180. So if I want to get a decimal approximation out of this, I can do 31 pi divided by 180 on my calculator. And that would come out to about 0.54. For B, so this is going to be 241 times pi over 180. Again, I see the degree symbol, so I know I'm dealing with something in degrees. So, go to my calculator, 241 pi divided by 180 is 4.21. Notice the lack of degree sign there. It tells me that this is radians. So to convert from radians to degrees, I'll multiply by 180 over pi. So 14 times 180 divided by pi is 802.14. And just for the record, I am writing the approximately equal instead of actually equal to, because I'm doing some rounding here. In D, again, I see the lack of degree symbol, so I know that this is a radian measure. So again, to convert to degrees, I'll multiply by 180 over pi. To do this, I'm going to use the fraction command on my calculator, so I'm going to press alpha and then the y equals button, and select the numerator over denominator option. Pi over 9, and then times. I'll go back and select the fraction command. (180 over pi). Press enter and I get 80. So here I'll use the straight equal sign because there was no rounding involved. Okay, 2 pi over 7. Again, I noticed no degree symbol, so I know I'm talking about radians. So I'll multiply by 180 over pi, and I'm going to do the same thing I just did before. So alpha y equals, and then first option, 2 pi over 7 times alpha y equals 180 over pi. That's going to be about 51.4 degrees. This is in degrees, so to convert it to radians, I need to do pi over 180. So 109 pi divided by 180 is 1.90. This is got no degree sign, so I know it's in radians, so it's going to be 180 over pi is my conversion factor. And again, I'll do this as a fraction times a fraction, so 9 pi over 4 times, oops, just one time symbol, 180 over pi, and get that guy out there. It's going to give me 405. And again, I can use a straight equal sign there because I did no rounding, as opposed to that one, which I did do rounding on. I, no degree symbol, so I know this is radians. So I'll multiply by 180 over pi. So 9.5 times 180 divided by pi gives me 544.31. couple more here that I missed. So 320 is, I know the degree sign, so to get it to radians, I'll do pi over 180. So 320 pi divided by 180 is going to be 5.59 approximately. And then 4 has no degree symbol after it, so I know that's talking about a radian measure. So I'll multiply that by pi over 180. I mean 180 over pi. I think I spoke the wrong thing. So that gives me about 229.18 degrees. On to the next page. So here, this R1, S1, theta, the picture that I'm imagining here is I have like a pair of circumscribed circles. So if I do that, here's my angle theta. This arc length here is S1. This arc length here is S2. This radius here is R1. And this radius here is R2. So I can just use my formulas here I'm given to solve these appropriately. So in the first situation, my angle I'm given is in radians, so I should be using the radian one. So to figure out S1, I know theta and I know R1, so I can just plug those in together. So I can do 3 pi over 2 times 3.5. That's going to give me 16.49. For the second one, I know S2 is 2 pi, and I'm looking for R2 times theta. So to get R2, I just need to divide 2 pi by 3 pi over 2. So I'm going to do 2 pi divided by, and I'm going to put a parenthesis and pick that fraction command and do 3 pi over 2. And that gives me 1.33 approximately. So if I look at the next line, here I'm given something in degrees, so I know I have to use the degree version of our formula. And just like in the previous one, we're given S1 is 3.26. We need to find R1, and we know that theta is 47. And then we have this pi over 180 here at the end. So I'm going to divide both sides by 47 times pi over 180. So I'll do 3.26 divided by, I'll do a parenthesis, 47 times, and I'll retrieve my fraction command, and do pi over 180. Oops. My parenthesis needs to be over here. And press enter. And that's going to give me 3.97. The second one, we have everything we need. We have theta, and we have R2. So we can find S2 immediately by just applying my formula. So I'm going to do 9.47 times 47 times alpha y equals pi over 180. And that's 7.77. For the next one, so note here that there's no degree sign, so I must be talking about radians. So I'm going to be using this radiance formula. I have my theta and I have my R1, so all I need is my S1, so I can just go straight to my formula and do 3.22 times 8.73. I can just multiply the angle measure and the radius. I forgot a 2 there, so I'll just go and insert 1. And that gives me 28.11. In this problem, just like up here, we know S2. We don't know R2, but we do know the angle measure. So I'll just divide both sides by 3.22. So I'm going to do 19.47 divided by 3.22. And that's 605. And I'm done with that. Moving on to the next one. It says find the perimeter of a sector created by a 3.1 radian angle intersecting a circle of radius 18.1. So we're going to have a sector is like a slice of pizza. So I have 3.1 radians, and then each of these sides of my sector is a radius of the circle. So my perimeter is going to be radius plus arc length. So radius plus arc length. So in our case, the radius for the radii is 18.1. And the arc length, since we're given it in our angle in radians, is just going to be angle times radius. So I can do this onto my calculator. 18.1 plus 18.1 plus 3.1 times 18.1. I get 92.31. And the unit here was inches. These are inches. Part B says find the perimeter of a 10-degree sector cut from a circular disk of radius 11. So again, a sector is a slice of pizza. This is 10 degrees. Each of these are 11. They're both radii. So here my perimeter is again going to be radius plus arc length. So not much has changed except because I'm given an angle in degrees. I know to find my arc length, I have to use the arc length formula. So I have 11 times theta times pi over 180. So slightly different arc length formula. Again, the arc length formula I used was these ones up here. So I have 11 plus 11 plus 11 times 10 times pi over 180, and that gives me 23.92. It says a 100-degree arc of a circle has a length of 7 centimeters. What is the radius of the circle? So this one's a little bit tricky because you did have to remember a fact from geometry. So the fact that you had to remember was that the arc measure is equal to the central angle. So I can then say that the arc length is 7, should equal the radius times that central angle, and since we're in degrees, we have to also multiply by pi over 180. I can just use the arc length formula for degrees, so I just need to divide both sides by 10 times pi over 180. So 7 divided by 10 times fraction pi over 180. Oops. I'll put those parentheses in the right spot. And that tells me the radius is about 40 point, oops, didn't remember, 11. And since we're in centimeters here, we're in centimeters. This one was inches. On to the next one. So find the remaining sides of the special right triangles. To do this, you have to remember the ratios for our special right triangles. So in a 45, 45, 90, the ratios are x, x, and x squared root 2. For a 30, 60, 90, the side opposite to 30 is the x, the side opposite to 60 is the x squared 3, and the hypotenuse is the 2x. In the first triangle, I see that this is a 45, 45, 90. I can tell just by reading the angles. So this side must be x, so this side is also x, and this side is x squared root 2. And I'm done. Not much to do there. For part B, this is a 30, 60, 90. So since this is the hypotenuse, this side is 2x, which in turn tells me x is 3 when I divide both sides by 2. So my x side here is 3, and my x square root 3 side is 3 squared 3. If I look at C, this side is the x square root 3 side, so x is 12 divided by the square root of 3, or when I rationalize my denominators, I have 12 square root 3 over 3, but that reduces down, holy smokes, to 4 square root 3. So that's my x side, 4 square root 3. So my 2x side is going to be 2 times 4, or 8 square root 3. And then my last one, this is a 45, 45, 90. I know the hypotenuse in that is equal to x square root 2. I divide both sides by square root 2 to give me 10 divided by square root 2. Rationalize my denominator, that gives me 10 root 2 over 2, which reduces to 5 root 2. So that's my x side, so both legs are 5 square root 2. So in question 5, we want to find the value for all 6 ratios for theta. The first thing I'm going to do is use the Pythagorean Theorem to figure out my other missing side length. So I have square root of 6 squared plus 5 squared. 6 squared is 36. 5 squared is 25. 25 plus 36 is square root 61. So sine theta. So we're talking about theta here is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. And cotangent theta is the reciprocal of tangent. But however, don't like the radical in my denominator for sine and cosine. So when I multiply both sides by root 61, I'm left with 6 root 61 over 61 and 5 root 61 over 61. For b, again, I need to find that side length AB. So I'm going to use the Pythagorean Theorem to do that. So I have square root 9 squared minus 4 squared. 9 squared is 81. 4 squared is 16. This 81 minus 16 is 75. The square root of 75 simplifies because it's the square root of 25 times the square root of 3. So it just turns into 5 square root 3. So, same thing as I did before. So sine theta, again, the theta we're talking about, it's labeled right there, is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta is the reciprocal of sine. But I need to rationalize my denominators. So that's going to give me 9 square root 3 over 15. And that reduces to 3 square root 3 over 5. Secant theta is the reciprocal, so that's 9 over 4. And cotangent theta is the reciprocal, so that's 4 over 5 root 3. But I don't like that as my final answer because of the square root in the denominator. So I multiply the top and bottom by root 3. I get 4 root 3 over 15. And that does not reduce, so that's fine for final answer. So it says in question 6, find the value of all remaining 5 ratios for angle theta. So I would start by drawing myself a triangle and labeling my angle theta. So I know sine is opposite over hypotenuse. So to figure out that third side, I can use the Pythagorean Theorem. To do that, I get 13 squared is 169, minus 5 squared is 25, 169 minus 25 is 144, and the square root of that is 12. So, to fill in the rest of them, cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine, and cotangent theta is the reciprocal of for B, I'm going to start the same way. Draw an angle, or draw a triangle, pick an angle, call it theta. Cosine is adjacent over hypotenuse. If I use the Pythagorean Theorem, I can then solve for the third side. 5 squared is 25 minus 4 squared, which is 16. 25 minus 16 is 9. Square root of 9 is 3. So I have sine theta equals 3 over 5. Tangent theta is equal to opposite over adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. For C, so I have, start by drawing my triangle, labeling an angle theta. Tangent is opposite over adjacent. And then I can use the Pythagorean Theorem to figure out that third side. So let's do that real quick. 24 squared is too big for me at this time of day. So 24 squared plus 7 squared is 625, and I recognize that is a perfect square of 15. Oh, I was wrong. It's up 25. At least I knew it was a perfect square, though. Sometimes you forget, folks. It happens. So there's that. So now I just need to fill out. So I know sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant. Oh, I did tangent. I didn't need to write that one down. Anyways, that's the reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. I didn't need to write that one down. It's already right here. I'm silly. All right, last one here. So again, start by drawing myself a little triangle, picking an angle and calling it theta. Cosecant is hypotenuse over opposite. So I can use the Pythagorean Theorem then to solve for that third side. So 169 minus 144 is 25, and the square root of 25 is 5. So sine, I know, is the reciprocal of cosecant. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Already did cosecant, it's already right here. Secant theta is the reciprocal of cosine, and cotangent theta is the reciprocal of tangent. We're all done with those. Question 7 is a story problem. So first step in any good story problem is to draw yourself a picture. It says you're standing exactly 300 feet away from a tree, from the base of a tree, 300 feet. You measure an angle of elevation to the top of the tree is 48 degrees. So here's the tree, and if I'm angle of elevation, it means that that angle there is, I don't know why I wrote 52 when it clearly says 48. And it's asking for the height of the tree. So we are referencing this angle because that's the angle we know stuff about. We know that trees meet the ground at a right angle, or we'll assume that. I guess not all trees do that. And then I know that the side I want is opposite, and the side I know is adjacent. So the trig function involves opposite and adjacent is tangent. So to solve for x, I'll multiply both sides by 300. And then type this into my calculator. Ding, ding, ding. Important note. The angle measure we're using in this problem is 48 degrees. Before I type in sine, cosine, or tangent to my calculator, I need to make sure the mode of my calculator matches the angle measurement in my problem. So I need to make sure I change this from radians to degrees before I start. Gotta remember to do that every single time for every single problem, or else you're gonna have problems. So 300 times tan 48 is 333.18 feet. All right, next one. You're standing in your yard. You notice your friend is on your roof. Your crazy friend. Your friend measures an angle of depression to you of 26 degrees. And we know our roof is exactly 22 feet tall. How far away is your friend? So here's your friend up on the roof. They look down at you, and I say that's 26 degrees. So an angle of depression is like that. And it tells us that the roof is 22 feet tall, and we're looking for side x. So, using the angle that I know, relative to this angle, I'm concerned about opposite and adjacent. So the trig function I should use is, once again, tangent. And I know tangent is opposite over adjacent. So to solve for x, I'll multiply both sides by 22. And I know that my calculator is still in degree mode because I just changed it just not even like a minute ago. So I'll just go ahead and type 22 times tan 26. And I'll get that my friend is 10.7 feet away from... Oh, but that's not really what I'm looking for. How far is my friend away from me is not this side. Oh no, it's this side, right? That's the actual distance from us. Me to my friend is that side, so I don't want tangent of 26. what side am I looking for? I'm looking for this side. I know adjacent, and that's the hypotenuse, so I want to use cosine of 26. Oh no! So, to solve this, I'll multiply both sides by y to get rid of my fraction. And then divide both sides by cosine of 26. And now I'll type that into my calculator. Gee golly willikers, reading comprehension is pretty tough. So, you gotta make sure that you read those problems and understand what they're asking for. There we go, my friend is 24.47 feet away from me. Does that make sense? Well, the hypotenuse is the longest side. We found this other side was 10.7. We did that on accident. And hypotenuse 24.4 is bigger than 22, so it's definitely the longest side. So that seems to make sense to me, so I'm going to go with it. Question 8 asks to find two angles coterminal with each angle. So, if I have an angle in degrees, I can find an angle in coterminal to it just by adding or subtracting. You could do either one. 360, so there's like infinitely many answers to this. So, one answer is 508. And I'm going to look at the calculator full time, I think. That'll be easier. Okay. And then to get another angle, I'll just add another 360, or if you were subtracting, subtract another 360. It doesn't matter. Make sure you label them as degrees, though. For B, this is in radians, so 360 in radians is 2 pi. So we're just going to be adding 2 pi each time. I'll show you a neat little trick here to get around the adding fractions. Not that adding fractions is hard, but to save yourself some time, I'm just going to drop the pi's. So I'm going to do 2/7 plus 2, and then I'm going to press the math button and select the fraction command. So that's really 16/7, and then I'm just going to put the pi's back in there. Whoa! Nice little shortcut. And then I'll just add another 2 pi to this to get my other answer, which is 30/7, or 30 pi over 7. Whoa! That was easy.
Gabrielle Phillips, your ride is waiting. Go on outside. Gabrielle Phillips.
Next one, we will, again, since we're in degrees, we can find our coterminal angle by just adding 360. So it's going to be 145. I can just add 360 again. You could subtract 360. You could subtract 2 pi. I don't really dig negative numbers, so if I have a choice, I usually add. Here, 1,000 degrees, oh my goodness. Let's just, for the sake of argument, let's subtract this time. That 1,000 is pretty big. Making these angles bigger is probably not very advantageous to us. In fact, it'll be a little less writing to subtract here, fewer digits to write down and all that. So I got 640 as one answer. Then just subtract another 360. That's 280 as a second answer. And those are both a little bit more reasonably sized angles than the 1,000. Okay, looking at E. So this is radians, right? We don't see any degree symbol. So I can do that. And then if I add 2 pi again, I get that. It doesn't ask me to round my answer, so these are fine. If you type that into your calculator and got a decimal, that would be okay too. Rounded it to like the hundredths place or whatever. That's okay. But this answer is okay too. So let's just stick with that. Notice I didn't have to add these because the 2 isn't in terms of pi. All right. Next up, negative 15 pi over 4. Clearly that's a radian measure, so I'm just going to add 15 fourths plus 2. And then math fraction command gives me negative 7 pi over 4. Again, I dropped the pi's to put it in my calculator and just put the pi's back in at the end. It's no big deal. And I will add another 2 pi to this. But in my calculator, I'm just going to add in plus 2. That's going to give me 1 pi over 4. Or you could just write that as pi over 4. You don't need to put the 1 there. But whatevs. So we'll add 360 because we're degrees, right? Obviously. And then add 360 again. That one I could do without the calculator because the numbers were convenient. Oh no, radians again. So we'll just add 2 pi to this. But to do that on my calculator, oops, I forgot the fraction command. It's okay, I can do it after. That's going to give me 13 pi over 3. And we'll just add another 2 pi. And we get 19 pi over 3. So that's easy enough, right? Use your calculator, it'll help, especially with the fractions, right? Not that you can't do it by hand, it's time consuming. And I mean, for saving myself some time. Okay, next up, we have this where it says, given a point in the coordinate plane, find all 6 trig ratios for the angle that's formed. So I'm going to start by just kind of sketching a picture of where this point is at. So 3, negative 4 is somewhere down here. This is like the terminal side of my angle. So the angle theta that I'm making is right here. So that triangle that I'm making always goes back to the x-axis is here. So I know that to get down to that point P, we had to go minus 4 down, and then 3 to the right. To find the hypotenuse, then I can use the Pythagorean Theorem. I'm not going to write any of that down. I'm just going to hope that you trust me that it's 5. And now I just do sine, cosine, tangent, just like I've done before. So sine theta is, and by theta, the angle we're talking about is this one over here. Always the one that's formed relative to the x-axis is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sine is cosecant is the reciprocal of sine. That's negative 5/4. Secant is the reciprocal of cosine, so that's 5/3. And cotangent is the reciprocal of tangent, so that's negative 3/4. Okay. Next one up is 3/6, or 3 over 6 up is somewhere about there. So the angle that I'm forming is right here. So the triangle I'm going to draw is always back down to the x-axis. To make that, we went 3 over and then 6 up. To do the Pythagorean Theorem, 3 squared is 9, 6 squared is 36, 9 plus 36 is the square root of 45, which simplifies down to 3 root 5. I'll let you check that. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent is opposite. Cosecant is the reciprocal, so 3 of sine. Secant is the reciprocal of cosine. 3 root 5 over 3, and tangent is the reciprocal, or tangent is the reciprocal of cotangent, which is this. So notice here a couple of things. We want to rationalize our denominator. This is 6 root 5 over 15, and that reduces, so that becomes a 5, and that becomes a 2. Similarly, we want to do the same thing here, rationalize our denominator, so we have 3 root 5 over 9. Again, that's going to reduce, so that goes away, and that becomes a 3. 6 over 3 is just 2. 3 over 6 is just a half. So a little bit of reducing to do there at the end. Jeepers creepers. So negative 7, 9 is 7 over, or negative 7, negative 24 is somewhere over here. So the angle I make is like this one. So again, draw my triangle, always back to the x-axis. So we went 20, or minus 7, because we went to the left, and minus 24, because we went down. And now if I want to calculate the hypotenuse, I have to do the Pythagorean Theorem. I'm going to use the calculator to chicken out and do this. So the square root of 7 squared plus 24 squared. Notice I dropped the negative sign since squaring them gets rid of the negative anyways. Is the 25. I think we might have did that already. Gosh, I can't believe I didn't remember that. Okay. So, sine theta is going to be opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Note that reduces to just positive 24 over 7. Okay. Cosecant is the reciprocal of sine, so that's negative 25 over 24. Secant is the reciprocal of cosine, so that's negative 25 over 7. And cotangent is the reciprocal of tangent, so that's positive 7 over 24. And my last one for this section is negative 8, 6. So if I draw that, it's somewhere 8 to the left and then 6 up. So there's my angle. To make my triangle, I always draw to the x-axis. So that's that. So I went negative 8 units to the left and then 6 units up. If I do the Pythagorean Theorem on this, I get 10 for the hypotenuse. You'll just have to take my word for it. I did it in my head. Yes, I did. So sine theta is opposite over hypotenuse, and that reduces to 3/5. Cosine is adjacent over hypotenuse, and that reduces to negative 4/5. Tangent is opposite over adjacent, which reduces to negative 3/4. And then cosecant theta is the reciprocal of sine, so that's 5/3. Secant is the reciprocal of cosine, so that's negative 5/4. And cotangent is the reciprocal of tangent, so that's negative 4/3. And on to the next one. So 10 says use the unit circle to find the exact value for each of these. Let's pull up our unit circle and look at that while we're doing this. I put it in this folder. There it is. So if you turn to the end of the review, you'll also see that there is a unit circle there. Don't mind my grad school textbook. It looks very scary, and it sometimes is kind of scary. Alright, so the first one says 11 pi over 3. Notice that 11 pi over 3 is not one of the radian measures on our unit circle. So how would I use the unit circle to do this? Well, 11 pi over 3 has to be then coterminal to something on the unit circle if I'm asking to use it. So let's see what it's coterminal to. The easiest way to think about this is to think about 11/3 as a mixed number. So 11/3 is 3 and 2/3. So if I go and I use my unit circle, so that's a half a pi, 1 pi, 1 1/2, 2, 2 1/2, 3, and then 2/3 more puts me right to here. Remember, the big wedges are 30 degrees, and the little wedges are 15. So 30, 15 more is 45, and 15 more is 60. So it's going to be right there. So 4/3 pi over 3 is the same. And I remember that the unit circle, the x-coordinate is cosine, and the y-coordinate is sine. So my answer here is negative square root 3 over 2. cosecant of 13 pi over 6. So if I, again, write this as a mixed number, that's 2 and 1/6. So if I do the same thing, so half, 1, 1 1/2, 2, and 1/6 more is right here. I remember that cosecant is the reciprocal of sine. So the y-coordinate is sine. So the reciprocal of that is 2. Boom. Tangent of 495. Well, I know that 495 is not an angle on my unit circle. So I'm just going to find something coterminal to that. So to do that, I'll just subtract 360 until I get something between 0 and 360. So if I subtract 360 from this, I get 135. So that's actually the angle that I'm interested in. So 135 is here. So tangent is y over x. So it is sine over cosine. And notice that these are the two same values other than one is negative. So when I do root 2 over 2 divided by negative root 2 over 2, you just get negative 1. It'd be like negative 7 over positive 7. It just becomes negative 1. It's not so bad. Cosine of negative 120. So remember, for negative angles, we're just moving clockwise. So we have negative 90, and then 30 more puts me right here at 240. And cosine is the x-coordinate, so I have negative 1/2. So next one up is cotangent of 9 over 2. So 9 over 2 should be easy for you guys to write as a mixed number. That's just 4 1/2. So half, 1, 1 1/2, 2, 2 1/2, 3, 3 1/2, 4 1/2. So cotangent is the reciprocal of tangent. We said that tangent was sine over cosine. So tangent would be 1 over 0. So cotangent is just going to be 0 over 1. And 0 over 1 is just 0. Sine of negative 5/4. Well, that one I can do without having to mess around with it at all. So we have just starting negative. So we have, this is negative 1 1/4. So negative 1/2, negative 1, and then 1/4 more is here at 3 pi over 4. And sine is the y-coordinate, so that's just positive square root 2 over 2. Secant of negative 225. Oops, picked the wrong thing. I don't need a calculator to do this. In fact, we're not supposed to be using a calculator to do this. So negative 225, I'm going to start moving clockwise. So we have 90, 180, and then 45 more puts me to here. So that's 135 again. Secant is the reciprocal of cosine. So the reciprocal of negative square root 2 over 2 is negative 2 over the square root of 2. But that simplifies because we have to rationalize the denominator. And then the 2's cancel, and I'm left with just negative root 2. Last one is cosine of 780. I'm going to start by subtracting some 360s from this. So the first time when I subtract 360, I get 420. And I'll subtract 360 again, and that's going to give me 60. So I just really need to calculate the cosine of 60 degrees, which is right here, and it's 1/2. So again, all I'm doing is, when I'm subtracting those 360s there, is I'm finding an angle that's coterminal to it. Very similar to what I'm doing when I'm writing these radian ones as a mixed number and counting around. It's still, I'm finding an angle on the unit circle that's coterminal to it. It's just the easiest, what I find the easier way to deal with it, whether it's in radians or degrees. Okay, question 11. So it says find sine if secant is -3 and tangent is positive. So here I'm going to start by drawing a picture, and you really kind of need to draw this picture. It's going to be super duper important. And the first thing I'm going to do is I'm going to label my all silly turtles crawl. Remember, this is an acronym to remember when sine, cosine, or tangent is positive. So the first thing I'm going to do is deal with this piece of information that secant of theta is -3. So I know secant is going to be negative wherever sine or wherever cosine is negative, because secant is just the reciprocal of cosine. So I know cosine is negative in the second quadrant and third quadrants. Remember, when we write the letter there, that's the function that's positive in that quadrant. Anything else would be negative. The A is for all. Sine, cosine, tangent. Tangent is positive in the third quadrant and first quadrant. So the place where both things happen, where secant is negative and tangent is positive, is here in the third quadrant. So that's the first step, is to figure out what quadrant we're in. Now we're going to draw our angle. So on our initial side, and then we have a terminal side in that third quadrant. It doesn't really matter where you put it in there. So this is my angle theta that I'm drawing here. So I'm going to start by picking a point on that terminal side and drawing our triangle back to the x-axis. It's always got to be the x-axis. Secant, I remember, is hypotenuse over adjacent. So this angle that we're talking about is always the one that's relative to the x-axis. So relative to this, the hypotenuse is 3. The hypotenuse is always the positive part, which means the adjacent has to be the negative part. And if I use the Pythagorean Theorem, then this side is 2√2. You're going to have to trust me that that's what it comes out to. If you don't believe me, please check. And now here's the important part. We're in the third quadrant. This side length is not really a side length. It's going to be the y-coordinate at this point P. So to get to this point P, we went 1 unit to the left, so the x-coordinate is negative. And then we went 2 square root of 2 units down. Since we're going down, that has to be negative, so that needs to be a negative. Now, and only now, I'm ready to find sine of theta. So, sine is opposite over hypotenuse. Done. I know, the setup is the hard part. If you get this picture drawn correctly, you'll get the right answer at the end, I promise. The picture is the hard part. Okay, so for the next one, again, all silly turtles crawl. Tangent is positive in the third quadrant and in the first quadrant. Sine is negative in the third and fourth quadrants. What quadrant do we want to work in? Well, the third quadrant, obviously, it's where both things are true. So I'll draw my angle somewhere down there into the third quadrant. I'll start by picking a point on that terminal side and draw my triangle, always drawing it back to the x-axis. Tangent, and the theta that we're talking about here now is this angle of our triangle, is always opposite over adjacent. Put them in the right places. So 2 over 1. I can use the Pythagorean Theorem to find this third side. You're going to have to trust me that it's the square root of 5. If you don't believe me, try it for yourself. But we're not done yet. Remember that these sides of this triangle aren't really sides of a triangle. They're coordinates at this point. Notice to get to this point, I went 1 unit to the left. So that's really -1. I went 2 units down. So that's really -2. Gotta make sure I get those signs in there correctly. And now, and only now, I'm ready to calculate secant of theta. So I remember that secant is the hypotenuse, square root of 5, over the adjacent, which is -1, or negative square root of 5. You got to make sure you get those signs right. You got to draw that picture. You got to think about what quadrant that terminal side is in, and make sure that the sides of your triangle are labeled correctly as negative or positive, or you're going to make a mistake. Really important. All right, next one. Cosine is negative in the second and third quadrants. Sine is positive in the second and first quadrants. I need to be working in the second quadrant because that's where both parts of those, or both parts were true. So I'll draw my angle. So there's my angle. Oops. I don't know, whatever, it can be in green. Pick a point on that terminal side, draw my triangle back down to the x-axis. I'm always going to be drawing to the x-axis. Don't forget that. Cosine is adjacent over hypotenuse. So I know the hypotenuse is never negative, so that means the adjacent side needs to be negative. And then if I use the Pythagorean Theorem to solve for this other side, I get square root 2. If you don't believe me, try it for yourself. I promise you that's what you get, though. And now remember, this sides of these triangles are not really sides, but they're coordinates for this point P. To get to P, we go square root 2 units to the left, so that's negative root 2, so the negative sign is there, that's okay. We go up square root 2. Up is positive, so it's going to be positive square root 2, so that one is fine. Didn't have to change any signs here, but that's not usually the case. You got to make sure you're checking to see if those signs change. All right, and now we're ready to do tangent. So the angle that we're talking about is always this angle. So tangent is opposite over adjacent, which just reduces down to -1. And we have just finished the entire study guide. Good luck on the test. I'll see you guys later.